Now we're going to our first pure inverter maker in our conference. Very happy to have with us Dr. Julian Mattheis, who is the CEO of Solarnative, a solar startup based out of Germany. And he will talk about the power of microinverters enabling new applications. Julian, the floor is yours.
Okay, I'll try again. Now it's better. Okay, is it better now?
Yeah, we can see you. We can hear you loud and clear.
Okay, excellent. Thanks a lot, Michael, for the introduction and also for giving me the opportunity of presenting here in this conference. I would like to present you our power stick microinverter and tell you a little bit about the applications that this microinverter is enabling. So what you see here is our microinverter, and this is our very special microinverter that is designed for integrating it into PV modules. Before I tell you a little bit about this, let me just introduce our company to you. We are Solarnative, and we are a very young company from Germany, a technology startup founded in 2019 by my partner Henk Oldenkamp and myself. Henk is actually the man who invented the microinverter back in the 1990s already. And since then, for almost 30 years, he's been optimizing his technology. And that's where we are. And we are finalizing the development and getting it into the market and launching the product this summer. Our microinverter is a little bit different than other microinverters. For those of you that are not familiar with the terms, a microinverter is an inverter that is designed to fit one individual solar panel. And what is very special about our microinverter is that it is much, much smaller than other competitors' designs. Typically, our inverter is by weight a factor 3 to 5 lighter than what the competition is doing, and also by volume, it is more than a factor of 5 smaller than the rest. With this inverter, we can achieve very, very high energy yield for the PV modules and very high safety of the system design. And very special for us is the long lifetime that we achieve with our excellent thermal management system. And also the cost is very low because we make it so small, and the highly expensive components, the inductive components, are very small. So what we are doing and how we are reaching this miniaturized design is by means of our high frequency technology. For inverters of all kinds, you need to convert DC electricity of the PV modules to AC electricity of the grids. And to do that, you need to switch energy packages back and forth. And normally people do that around frequencies of less than 100 kilohertz. And you can do that, you're switching relatively slowly, and then you have to transfer and store relatively large energy packages. And that makes the whole device very bulky, and also the inductive and capacitive components very expensive. So what we are doing is we are switching at a frequency of 1 to 2 megahertz. So we're switching around 20 times faster than the competition is doing. And this way we can really make everything much, much smaller. And also the energy packages, in our case, we switch them very fast in small packages. I mean, I guess many people want to do that, but the trick is actually how to reduce the losses. That's the challenge, because with every switching process, you have switching losses. So yeah, that's our core competence here, how we can achieve such high switching frequencies and still keep the losses low. Anyway, the miniaturized design has two advantages. I mean, one is that we really reduce the cost because the big and bulky inductive components are very expensive, and we really reduce exactly these high cost components. And the other advantage is that our inverter is so small, we can integrate it into the frame of a PV module. And by doing that, we convert a standard PV module into an AC module. And we use the frame as very efficient cooling. It's basically a huge cooling fin. And with that, we really achieve a much longer lifetime than without this cooling effect. Because a lot of the failure mechanisms, they are exponentially and temperature activated. So that means every 10 degrees cooler doubles the lifetime. So with this miniaturized microinverter, we are poised to really have PV modules that can directly be plugged into the grid. And this is actually what we're aiming for. And our dream, our vision is to make the AC module the new standard for residential PV. What does AC module mean? It is basically a PV module that is completely customized for AC application. I will come to the details later, but the advantage is that the inverter is an integral part of the module, and then the modules, they can basically just be plugged into the grid. So that makes the installation very, very easy. And this is also what we target to make life easy for the installers, because we believe that the installers will actually be the bottleneck of the energy transition. So we want to rather give us and our R&D team a headache and instead make life easy for the installers on the roof. Yeah, with the frame integration, our inverters fit into standard frames, but also we have developed a very special frame that you see here on the bottom left. Standard frames are open to the inside of the module, and our frame is open to the outside. And that gives further advantages and benefits for the cabling on the roof, because basically then you can just have the cables also guided and safely in these frames, and you don't need to leave the module plane for the cabling. With the module integration, there's also a lot of efficiency improvements and cost improvements, because the inverter itself takes over some very important parts of the module. For example, there's no bypass diodes needed. The inverter can control the reverse bias of the solar cells and avoid any kind of damage in partial shading situations. So you don't need any bypass diodes. You don't need 3 split junction boxes. There is no DC cabling, no expensive MC4 connectors. Everything becomes much easier. And the whole module does not have to be designed for 1000 or 1500 volts DC anymore. It can be customized for a low voltage application, because the DC voltage is just the VOC of a single module, so around 40 or maximum 60 volts. So you can use cheaper back sheets, for example, and also you can really reduce the edge distances and increase module efficiency up to 2%. We have one additional feature, that we have a very unique substring layout, where we basically connect 3 strings in the module in parallel, and with this we have an even better shading tolerance and performance in partial shading situations. The inverter also takes over the bypass diode function, and with this we have a very unique hotspot and hot cell protection, and it totally protects the cells from overheating. I will go into a special niche here, because the inverter is so small. It's also easy to combine it with lightweight modules and that do not have a standard frame. But what you see here is a frame from our cooperation partner, Matrix module. They have a full area cooling frame, and that really stabilizes the module. So it's not necessary to use a glass on the front side anymore. You can do that with plexiglass, for example. And our inverter uniquely fits into that. So that is also possible, and it is also possible to combine that with heat pumps. So then you have an AC module that is at the same time PV and solar thermal module. And I mean, all of you know that the perovskite cells, they are handled as the next big thing in solar, and they will lift the module efficiency from around 20% or a little bit higher to 30%. But the perovskite have a problem because they're very heat sensitive. So in this we can control. If we combine our inverter with perovskite cells, then we can protect the cells against overheating, and we can really make sure that they have a long lifetime. But this is only side remarks. I mean, for now, the applications are manifold because the complete system is so modular, and also the form flake factor plays a big role. We are starting with a balcony PV, which really has increased the market size a lot in the last 1 to 2 years. So that's a very simple system, and our inverter is perfectly designed for that. You just have 1 or 2 PV modules with 2 inverters and a small gateway for internet connection. Then, of course, there's the standard residential systems that are also very good for microinverters if the roofs are complicated. And here in Germany, we see that more and more the big and easy roofs that are perfectly facing south, they are vanishing, and installers are faced with more complicated roofs, different orientations, different shading conditions. And I mean, also the electricity consumption really increases, so they would really want to utilize the rooftop area, but it's difficult to do that with a standard string system, and it's much easier to do that with microinverters. And it is even more or easier when you have AC modules and don't have to do additional installation steps. So our system has a lot of detailed advantages that also make life easy for installers. For example, everything is plug and play. You do not need additional surge protection devices. Everything is automatic. Also, the mapping function on the roof. Everything is designed to really make it easy for installers. Oops, sorry. Yeah, and of course, you can build the modules on the roof, but also more and more we see building integration gaining traction. And this means, could mean facade integration like here, or it could mean integration into the roof. And in all cases, there's more requirements regarding partial shading conditions. So you really need to make sure to control each individual module. And also the safety requirements are much larger than compared to a rooftop system, which is above the roof and that does not have to fulfill the building norms. Another application is solar carports. You could do that with a string design also, but it's much better to do that with microinverters because mostly the carports also face partial shading conditions. They're not as high as rooftops mostly. And also the lower side, the bottom side of the modules, they are within reach of people. So you do not really want high voltages from the DC strings there. And it's much safer to do that with microinverters. And also the advantage here when using our AC modules is that all the cable is invisible. It's totally disappearing in the frames. And there's no cabling visible from the downside. Yeah, a similar application, which is more and more, we see an increasing market volume, is a so-called solar fence, where you place the modules vertically. And there also you do not want to have junction boxes on the backside, and you do not want to have open high voltage DC cabling. So here it's the same thing. The DC cables vanish. You have an integrated AC module, and then the total AC cabling and inverter is part of this mounting structure here. It is also possible to do that as agricultural PV, but these systems are probably mostly larger, and also the touch safety is not so important, so they are not a typical application of microinverters if the systems are too large. Yeah, but then also there's more other more special applications like solar blinds, and all of them again, they require special control of the individual modules. Same accounts for solar pavement. Everywhere where you have partial shading conditions and safety concerns is a particular good application for microinverters. And I'm sure there's more applications coming up. And the good thing is with the microinverter, you're sure you can do it completely modular from one module to many modules, and always you are very, very safe. And with this, I would like to come to our conclusion, and thank you very much.
Thanks, Julian. Great, you showed all these applications. It's also super that it's now really taking place. We've been waiting for such a long time for this to happen, and now it is starting to happen. Here, can you talk a little bit about your, I was actually out for 2 minutes because I had a little blackout here in Hanau. So just wondering if you could talk a little bit about your business model and about your ramp up strategy for Solarnative.
Yeah, with Solarnative being a startup, basically we start from zero with everything we're doing. And what we are doing is we are launching our balcony PV system this summer. We're starting in July. And in Germany, since the Ukraine crisis, the balcony segment has really exploded. And so this is where we're starting. And we see a lot of market demand there. And then towards the end of the year in Q4, we're launching our residential system.
I think what's really cool about your product is, of course, that you can put it into the frames of modules. So do you have or can you talk about your business plan or strategy there? Will you cooperate with module manufacturers, or how does that work?
Yeah, at the moment for the launch, we will basically do it like all the other microinverter companies, and have the microinverter separate from the modules so that it is compatible with standard PV modules. And in parallel, we are in discussion with many of the tier 1 module manufacturers to integrate the inverters into the PV modules, and then really have designated AC modules. And this we expect to launch with partners in mid 2024. So then we will not launch the AC modules ourselves. We will just supply the inverters to customers, to module manufacturers, and the module manufacturers then integrate the inverters in their factories into the modules.
Okay. And the modules, I think some of the inverter manufacturers today are also having outsourced to big electronics companies producing their inverters. You are doing it on your own.
Yes, we are currently ramping up our factory with a capacity of a gigawatt in Hofheim in Germany. That's in the Frankfurt area. And Yeah, in principle, it is a standard SMD manufacturing, but we have some special processes which are related to our form factor and to our unique thermal management that we're doing. So this would make it harder to do it with an outsourced EMS provider.
Okay, super. Thanks a lot. Looking very much forward to your product coming on the market. And okay, thanks. Let's continue.
Thanks a lot, Michael.